Hello, everyone, and welcome to the broadcast. I'm newtmechanist, and today we are continuing our game dev project. Hello there, Kaizen. We are doing some game development today. I see. Let's see. Nope popped in before the stream started. Schmuggum's in Tacitus here as well, and Kaizen. Hello, everyone. I think I finally found the source of one of our problems that showed itself last time. The rotation code, once again, being difficult. But I think I have an idea that I think will work. Before we get into that, though, let's check in with the kitties. We do have 4 of them visible. 1 additionally accounted for. Oh, there's the other. So 2 off camera. Hey, buddy. We have Sky and Sammy up in the tree, Ember across from the keyboard, Mason on the beds, Molly on my footrest, and Sherbet passing through getting some back scratches. You can see one of his paws on the table side. He must be rewarded anytime he swings through because he's real skittish. But you can tell he very much wants the attention. He just says, you can give it to me at full arm's reach, please. Oh, but yes. Let's see here. Twitch ad should be ending shortly, and then I will get into the details, but is the code still working? I was messing with it a bit yesterday, and so there might be some broken bits. Let's find out. Okay, let's add that rotation in. Okay. So it is functional. Let's show it going here. There we go. The Twitch ad has stopped. So this is showing what I'm going to call rotation here. The other thing is orbit, but this is rotation. And we have a projectile that is that has an additional force applied to it that is akin to, there are names for all of these things, but I'm going to call it kind of the speed around the edge, the edge force of the projectile. So it's applying that, and there's essentially like a little clock hand inside of it that decides where to apply that force, in what direction, and it just ticks around in a circle. I think so. I thought centripetal was the inward force, essentially kind of the pull of the cord, you know. But it's one of those words. it's one in that whole set of things. But this is rotation. So right now it's being told to rotate it, I think, 4 times a second. Okay. That scans then, Kaizen. That scans. So this one's logic is how often does it rotate per second, and that is applied to that clock hand. It's every second it rotates a particular amount. 4 times a second. By the end of that second, we are going to have gone 360 degrees 4 times. It's going to zoom around. For reference, since we're going at about 60 frames a second, I think we're generally going 0.016 times a second-ish. There's some wiggle to that. So we get a lot of the rotation here. This is also influenced by its random direction motion, so we're getting everything we want out of that. It doesn't look good like that, but that's the general behavior is what we want. The presence of that file is a mild spoiler to where we're going, but Okay, so rotations per second, again, is relevant to rotational movement, which is just that centripetal force. Orbital motion, and this is where the those two forces are more accurately applied. Orbital motion has a center point, and that center point essentially has a chord coming from it. It is the thing that is keeping it around it at a particular radius. So with that one, to simulate it, we have something similar to that centripetal force where we have a vector moving around, but that vector is always relative to the direction to the target. It does not rotate independently. Paired with that is a force coming from that central point that is either pulling or pushing back against it in order to get it to a particular radius. We essentially have a magic rope that we either pull on or push against. I guess you could view it as a post or something, but you know. These are two very different types of motion, and part of the problem has been that I've tried to keep them together. Hey there, sharpshooter, welcome. Welcome, everyone. If you do see me talking to, or if you hear me, or if you perceive that I am speaking to somebody you can't see in chat, it's because they're in one of the other two streams. I do simul-stream in two form factors on YouTube and on Twitch, so watch where you'd like to watch. Okay, so this is part where we have a splinter here. Mason is being extra cozy. Zoom in on Mason. Mason's a lovable little doofus. He does not have any cat grace. It's not that he's clumsy. He's still very nimble. It's that he doesn't have that sort of elegance of motion that you see in a lot of cats. It's all very straightforward. Molly is kind of clumsy, but not in a she'll fall over things. It's that anything that her paws could hit that would cause problems, they will. She is particularly fond of stepping all over my soundboard. Okay, so if we take this and we say services dot player state dot player, that in there. So we are redirecting it. We are overriding what it considers its goal to be, or how it's going to behave. We're giving it an entity target, which is going to change this to orbital motion. And orbital motion is very different. Because I can move around. In orbital motion, you'll see that there's some drag on the projectiles, but they get steadily hauled back in. We can apply other forces to them. And this is something that needs to be adjusted in the logic, is right now, this the orbital motion has very strong resistance to any other motion. We can put more randomness on it, and we can see that there is some drag on some of them, but it's still keeping the circle relatively well. Which is good that it keeps the circle, it's that it's resisting the other motion too much. Like, it's practically ignoring this one, though under the new model we do need to change how wave and zigzag motions work. We can apply forces on these, and we should. Anyhow, that's where we are. And as might be apparent, those are two really different sequences of behavior. It's orbital wants a central point. It doesn't need a central entity, it needs a point. And once it has that, it doesn't really use this clock hand logic. Because what it's going to do is it's always going to draw that line to its target. In this, physics is the entities move and the camera follows it. Let me show. Okay, we can kind of jerry rig this up. Because that orbit isn't necessarily always going to be the player. That's kind of the goal, Schmuggums, is to have that orbital eccentricity covered. Like, it should be able to happen. I want to get things like elliptical orbits out of it. Not that. Wrong one. Open containing folder. Data files. All right, let's maul this bullet a little bit more. Bit of a flashbang for you there. Let's see, heart. So this is the default value of the yarn bullet as far as its movement. One of the core defaults, and that's that it picks a target and says straight line to where that target was. We are going to remove this, but we need to make another one. Let's make another little testing friend here. Luckily, it doesn't need to be an item, so we have fewer things that we have to edit. This matters. I should make case not matter, but you will get there. All right, this is going to be a move rotate. All of the same stuff is technically true. But instead of targeter, we are going to, let's see, move fixed random entity. We'll switch targeter empty with target random enemy. So this is going to select an enemy that exists on the screen somewhere. And it's going to treat that as the center of rotation. This is not perfect. There is an edge case to this that will make it fiddly, but we'll get there. We're doing a lot of test code manipulation here lately, which means we will have to do a scrub pass on our data files after I'm done with all this mayhem. Okay, so let's double check. All right, so by default, when this starts, the yarn ball should be selecting a random target. Let's show that again. Let's give it a little bit of spread so we can see it. So these orbits are relative to one of the little blue blobs on the screen. So we can see that sort of elastic gravitation that it's got going is when it's far away, it pulls really hard to get within radius. When it's close up to its target radius, it slows down. Is this an end state weapon? Not at all. But it does create interesting use cases if the circle was actually tighter. So that the you could essentially be throwing a buzzsaw out around another target. It's possible that it will get hit on the way out, but then that enemy would be carrying damage around them. But that is another indication of why they're so different. Orbit needs tweaking as far as how it adjusts. This little boost factor that I've got in here is currently very powerful. So we need to tweak that. It should be visible. It should be apparent. Hey, we've got Mason and Sherbet on the bed now. It should be apparent that it's happening. We want it to occur, but it needs to be carefully controlled. So here, if we remove it, but again, let's get also rotation isn't being accounted for properly here. They're coming out in clusters. It should be coming out in a fan. So you can see if the pull isn't very strong, if they're too far away, they're never going to get in there. So figuring out what that, how we want that pull to be accomplished is going to be relevant. Because two elements of this is we don't want this so weak that it doesn't have any impact, but we also don't want it so strong that it stomps on all other movement. This should make it have a bigger impact than it does, but I think subsequent code is throwing it off. Yeah. We'll have to adjust a lot of this, but anywho. So part of our task today is to split orbiting off into this little guy so that we can focus any sort of logic specific to the rotations per second kind of spiraling forward pattern and the circling around something pattern. Because they both have important differences in their variables that we need to account for. Ugh. Okay. So let's get this back how it was. So I don't have too far to go. The yarn ball normally has movement bounce with it too. It creates like a vertical component to the movement. We still need to change a lot of these so that they are properly accounting for the new movement logic, but we'll get there. Okay, we've got that back. That's back. Okay. Quick double check. I do have a bailout in the loading logic, but I don't have an error aggregator in that loading logic that does things like these files failed to load kind of thing. But it will give up after a period. Okay, so there's our rotations per second model. Okay. So what we're going to be doing is we're going to get all of the stuff that is relevant to there being a target. And we're going to be pulling that over here. It's going to be a lot of little bits that we need to account for here. So most notably, I think the first thing is to have a JSON, ignore this, but it is a it's a vector. Because it's not a property, JSON doesn't intrinsically find it, but it's a nice little shorthand. It needs to be public because we are going to be messing with it in the copy. Molly is rolling around in the footrest, and she is snuggled up against my ankle. And part of that is that Molly's razor little kitten claws are currently hugging the top of the bottom of my ankle. It is unpleasant. Or we don't need to actually set these to this. This is actually the default value for both of them. We're just being explicit. Center set and center are primarily only relevant when there isn't a target entity. If there's a target entity, we're going to latch onto that. We're going to be updating the center constantly. General idea for this is as soon as there is an entity, orbit that entity. As soon as there isn't an entity, set the center to wherever you are right now, or keep it at wherever it was. So for the most part, center set is going to happen exactly once. And that's as soon as we make any calculation as to what the center is. So it will either be the position of the target entity or the position of the thing being moved, the entity. In this case, the yarnball bullet. Okay. So we're not going to use clock hand because that's irrelevant. So we need to account for this little bit of logic. Well, So this becomes relevant because we want to know, like, the distance to the target, that kind of thing. But once we have distance to target, we can mess with to target. All we want. So the fiddliness with orbit, one of the fiddly elements, it's fiddly elements all the way down. But one of the elements is if the target is right on top of the position there. No matter what, center is going to get set right after this part. By this point, center is set. In theory, it's set in both of these as well. But what that means is if we get here, then it is now set. So if we have a target, we set the center to that. Doesn't matter if center has been set. We always update to the target. Else, if not center set, so we're going to do this repeatedly. It's okay. A single Boolean set isn't going to end our program. I always mention these things because we are doing this constantly. For every entity, for every physics frame that uses a behavior like orbit, this will be happening. Potentially this will be this whole block could be happening multiple times. It doesn't mean we'll be time past executing. But, you know. Float, so I have it. One of these times I am going to take the time to change all references to delta to a float once it reaches C#. Mentioned it before, but Godot inexplicably passes delta as a double into C#. Inside all of the Godot side code, it's a float, and every reference in the C# Godot library, the interface, it's a float. Everything that Godot wants is a float. Nothing's a double, but it passes delta to you as a double. That and the fact that vector 2s are floats kind of contaminates a lot of the logic. So converting this over to a float would save me some pain. I do need to make sure if I do that, it's going to splash the change across a lot of files, and I want to do that when I'm not doing something else. Tangent resolved. Okay, so now we have a center. We don't care about the target anymore because we have a center. we do care about the target. We don't need the target's position anymore. We have a center. Just gonna So distance to center, it can mean that you're at the right radius. Like right here, that can be okay if it's at 0. What's not okay is if we are... Well, if it's 0, we're not going to move. So it's okay if this is 0 as a result of this. So if the distance is not where we want to be, then we're going to make adjustments. So we're going to move some of this inside of the if check here. So what we're going to want... I wonder what the first IntelliSense being helpful nonsense will be today. This one should actually be a property. Property so that it actually gets automatically swept up in JSON handling. Rotated. We will need to get to that logic anyway. All you rotated. Okay. Rotated is whenever we do that fan out logic, when we split into 3 in a fan of 90 degrees, we rotate the projectile. That doesn't mean the same thing to every kind of movement. For some movement, it doesn't do a thing. For some targeters, it doesn't do a thing. But, for example, if a targeter has a direction to it that is fixed, so when it's aiming at a random enemy, not homing to, just aiming at where they were, that will be a directional vector. Rotating that particular targeter is going to generally push it away from where it would normally go. So if it's doing 45 to the left and it was aiming at the target, it's going to miss to the left. With the assumption that the one that wasn't rotated won't miss like that. think we should rotate this as well in order to get this correct. So let's just get you in there. Okay. We need to define edge-based motion. We can call it the right thing this time, huh? Hey there, Donald. Welcome. Ah, average. Let's get these in here. There's another one hanging around. Where are you at? There you are. I am indeed, Donald. We are coding the game once more. I've got a what is the current and will surely be the last revision of how we're doing orbital and rotational movement for sure this time. That's the line. You need to have more faith in Pinky swears. One of these days, I'm going to, Tess, I'm going to drag you through watching Owl House so you get all of my references and my fanaticism. Okay, so that's our radial motion. Indeed, nope. I do enjoy the Owl House. I've watched Gurren Lagann. I also watched the exceptionally strange movie. But that doesn't mean, I wouldn't want to watch Gurren Lagann again. Owl House, I think, is an excellent example of... also, hello, Rando. Owl House is an excellent example of big problems, some of the big problems with, like, corporate streaming. Streaming logic. So it's things like, we want to put out all these cool shows, and we want to make a lot of money, but it costs money to create these shows. So if we don't get an immediate return on our streaming platform, then clearly these shows need to go. Owl House in particular, though, was more somebody wanted to swing their weight around. And they did, and it was a bit of a tragedy for a time that they did. My last watch through, I noticed at one point one of the characters asks another, like, are you sure you don't want to do like effectively they ask, are you sure you don't want to do like a beach episode? And the character turns to them and says, if we had like 20 more adventures, we had time for like 20 more adventures, yes, but we don't. No, we have to do the big climax thing right now because We've lost enough. We've lost all of our remaining time. Brain stalled. Okay, there. So we have radius motion determined. Then we need our centripetal motion here. So to get that, we need to extract this one. And we have our we don't need to move here. To move here. We need to move to B here. Need clockwise multiplier. Rotations per second isn't actually how we want to present it because there's no guarantee how many rotations per second we're going to do with orbital motion. That is entirely dependent on what radius we're at at any given moment, as well as the speed of the projectile at any given moment. Since both of those things are variable, we can't control that about an orbit. When it is just rotation, that is rotations per second controls how frequently we are turning we are turning the force that we're applying. But both of these need a clockwise multiplier, so let's get that in there. Yes, this is duplication of logic. I don't really mind. You what clockwise ultimately does is controls whether we multiply by -1 or not, in particular ways. This pattern making it so it's positive when we send clockwise in this way is... Man, that's messy. We must change this. Remove a magic value there. Let's... constant int. We'll do float for multiplication purposes. We'll do int so that we have proper constant purposes. Is anybody from a place that says it this way or heard it said anti-clockwise instead of counterclockwise? What's another one? It's like Widdershins and something else. Language is a whole thing. Is the other word. Okay, Widdershins is counterclockwise. One origin phrase to it is in the direction opposite the usual Widdershins. And apparently the opposite of it is either sunwise or diasil. Neat. The more you know. You're not going to do extra rotations per second. So we get those in place. So the default with these, setting aside boost, every time we apply motion, we apply it in terms of an assumed unit vector. It doesn't have to be a unit vector. It can be more or less than 1, but the default is 1 in length. If you want it to go faster, you make it more. If you want it to go slower, you make it less. Which, should be apparent, but it's effectively every movement gets its own slice of the speed, its own equal slice of the speed to use. So the assumption that it's always 1 means that you make use of the equal slice as is, but you can use more speed than you're given. So the projectile will speed up as a result of that. Its distance over ground will be potentially increased. This is not accounting for oppositional forces. Another way to view it is movement will get weird really easily. So if we want it to be consistent in how it moves, then orbit should always add 2. in that the centripetal movement can never be more than half the speed, but I don't think it needs to be that way. For now, we're only going to apply a movement if it's going to be there effectively. So we take this, pop you in there, just so. Okay, so if there is a radius-based move, we're going to add it in. The radius-based move now has the same weight as any other movement in it. And we always add in the centripetal move. There will always be a centripetal move. And then, because we did anything in this, we should set that the message was acted on. Some things have logic that says if this message hasn't been acted on, then behave differently. If nobody did anything with this. Most frequently, Schmuggums, it is less physics simulation. It is much more, this thing do exactly this. We are unlikely in the finished product to see just only what I am doing show itself. So it's unlikely that you will see just this makes the projectile circle a target kind of thing. You are just as likely to get this bullet orbits the player or similar by default. And this power-up causes it to orbit an enemy that is already targeted, or to get an enemy target, and in doing so it also applies this other really nice bonus. Everything is likely to come with and it gives you this really good thing. Okay, so we have our base motion here. We do need to get our rotate in. So all movement behaviors, all behaviors for the most part, can rotate. They don't necessarily do anything when they are rotated. So there is no clock hand. And we have Radian's rotated. Just so. This is another instance. Code is a way of thinking. Nope, it is a pattern of thought that you have to take on, you know? That's why the term vibe coding bothers me so much. If you are ignoring the whole logical pattern and you're just saying, yeah, it does a thing, there are going to be problems. Big problems. Okay, so we have our rotate handled. So speed is already right out. We can't control speed. The baseline, like, are you just using GD script? Nope. Or are you doing something else? Say you are trying to change the exit button to Q. part of the problem with vibe coding, especially as a term right now, is that it is steadily expanding to encompass all uses of AI in coding. And AI is a toolbox, a thing that you deploy as you are coding and saying just, hey, give me a for loop that does this, or draft me a function for this kind of thing. That is reasonable usage, because the viable assertion there is that you have a person that knows what they're doing and could do it, but they don't need to. Give me a stub of a for loop or a loop that iterates over this collection and increments all of them by one. You can do that, but this could save you time, and you can look at it and say, yeah, that's doing what I want. But it lumps that in with people that do not have that knowledge, are not even looking at the code. They're just saying, hey, code me up a web API to attach to this website to do this thing. Those are two really different things. One of them is a real problem very quickly. And hey there, Drew. Hey. In GDScript, nope, let me pull this up. I don't know if you've been there already, but I can pull up the relevant code here that might give you an idea. Where am I putting that? I think it's in game. Okay. So this is the kind of thing that you're generally looking for, is a particular message. There are other ways you can do this, but this is potentially easier. That's potentially the worst side of things there, Schmuggums. It's complaining about my test code. Is effectively brain drain. For every developer for every coding job that is encompassed by a prompt engineer or a project manager using AI software, that is potentially a rookie developer that isn't learning skills. Which means that is a person that will never become a senior developer. And so that is a person that will never train junior developers. You are creating a scenario where your knowledge base for actually coding is potentially shrinking. Will it go away? No. But it then feeds into, well, we can't get a junior developer cheap enough. Let's just have AI do it. Repeat and repeat and repeat. Anyhow, the input map. Okay. So this is an area to look if you're in GDScript there. Can't zoom this in. But this is in your project settings in your Godot project in your input map. This is where you can set up some generic things that Godot will often listen to by default. Yeah, Schmuggums, there are plenty of horror stories of... the classic horror story at this point is they had an AI an AI system that just, deleted their GitHub repo. Just purged their code base. But you can do things like UI cancel and similar, and you can set key codes in there. So I could go in and change UI cancel from being escape to something else. That way you can still refer to UI cancel as your operation that you're listening to. Similarly, like if you wanted to do control paste kind of stuff, you have those sort of commands in here by default and can add or remove to them from them. But that's a good place to look. Anywho. What was I doing? Well, I'm heading into a break right now. We do have a Twitch break going. I will be back in just a couple of minutes. If you like what you've seen and have not already, consider liking, following, subscribing, dropping a comment. All of those things are good for the channel. But with that said, I will be right back. And we're back. Oh. Okay. So this one, we need it to have rotations per second. Radius is not relevant. So let's get all of this out of move rotate. Clockwise, we still want. We're going to take this same logic up here. Is this duplication? Yes, it is, but there's no certainty that this will always work the same way. This is relevant, though. We still need to do that. Speed, we can't control. We need to keep clock hand. We need to keep rotated. Float. Does not have a center. There's no fixed center here. We do have a radian increment. We are going to change this. This becomes a property. Hey there, Billboard. Welcome, welcome. We're ripping up floorboards. This isn't quite right. We should be applying this elsewhere, and we'll do that in a moment. There's no minimum radius. Get to you in a moment. We are never updating the radius because there is no radius. Put you here. This is unlikely to change ever, but we can just ensure that it's set here. Do I like apples? I do not dislike apples. Don't have radius-based motion. So we can just rip all of that out. Okay, so if we don't have a clock hand yet, we're going to get one. So first, we're going to get the current proposed velocity. That is fiddly. Well, not really. What this does is looks at the entity and says all of the movement that you have queued up this turn, this time slice, tell me what it is. Give me give me that direction. So if we have a direction from that, we are going to reverse it. Otherwise, we're going to get, we're going to use to the right. Why are we reversing it? Well, thanks for swinging through, Billboard. Okay, this offsets the clock hand. Okay. But only initially. Which isn't really what we want. So we need to think on how to do rotation for this little guy first. Well, eventually. There. There. I'll mention this. So for the purposes of especially move rotate, putting pi in here is So the distance around the circle that it's tracing is 2 pi r. So the radius times 2 pi, or pi times the diameter, whichever you want. So equivalent to moving, if it were just moving in a straight line, covering the distance of the radius in the course of a second, then it will have traced rotations per second times 2 pi r. We're throwing that in there. I think technically there should be a 2 here. So this is our... In the time it would take you to cross the radius, you're actually going around the circle that many times. That is the current assertion. This isn't quite accurate, but we're saying since it's rotations per second, this is what we're doing. We can always adjust that more. But this amplifies it greatly. This way, the projectile doesn't slow to a crawl by using this, since the distance around an arc like this is going to be a great deal longer than the linear distance it's moving. We can save some calculation by doing this. Bouncing around the data less that way. So move rotate is going to need an offset, and that is an inward or an outward change in the rotation. So by default, we have a clock hand and we're kind of ticking it around in a circle based on our radian increment here. So 4 rotations per second, whether it's counterclockwise or clockwise, gives us an amount of change on the circle. What slice of the pie do we move per second? So that gets applied to the clock hand, and then we take the orthogonal of it, which is it's a 90-degree angle in a very particular way. There should be 2 extra rotations that happen here. Is one that says, should I start spreading inward or outward into the rotation? So should the spiral tighten or expand? Things get fiddly here, but we do need to change this so it's not rotations per second. We need to come up with something else. But we should handle that, and we also need to make it so that the rotation, this radians rotated, should impact more of this logic. So it's the orthogonal is where we want to mess with some stuff. It's the clock hand stays the same, but the movement vector gets changed a little bit. We will cross that bridge in a little bit, though. So rotations per second will be passed in. Both of these should work. Now we need to update the files for it. We are going to temporarily make use of these differently. Target the player. Does not have rotations. It has a target radius. What is the other property? Has a radius change. Has a count clockwise or a counterclockwise. We are going to change at 96 per second. Doesn't have a radius per second, but it does have a clockwise. Okay, so rotate in is going to use move orbit. It will center around the player and it will try to be 2 squares out within 2 seconds. Rotate out does not have its own target, but will just start rotating accordingly at about 2 rotations per second. If we did this right, everything is about to work. So let's do a build. Okay, there's no problems in the raw code compilation. The files load. Here's an orbital. It does nothing. Okay, well that's still that's technically working. Let's make it more visible. That's that multiplier this is the multiplier issue, is how quickly do I make it orbit kind of stuff. Okay, that's working. There is something wrong with this little bit here. So we're going to go into our move orbit. Okay, so we are getting into it. We have no target. It's very weird. Okay. Well, we have a bunch of these that aren't being copied correctly. So let's fix all of that first. So let's see here. Center set, center. Radians rotated. Target radius. Radius change. Clockwise. Okay. Could I try to do this programmatically? Yes. I don't want to go. That's a can of worms I don't want to open. All right. I think that's working. Oh, okay. Okay, those ones spiraling in are because of the change that we did to how they're rotating, to the rotate aspect, the radians rotate aspect. So how we're using this. So this is rotating our movement direction before the orthogonal. I think we'll still have our problem if we move the rotate down here. Same problem. The ones that, yeah, so some of them are having that rotation applied very, very tightly. And we're never getting a target entity, which is weird. Oh. No, that's... We'll step into this and see. Weird. Stepping right into that. That's very strange. Oh, hey. It's our 410th follower over there on Twitch. I missed the pop-up. Let's see if I can find that. Who was the one what triggered confetti? Is it Naurico? Naurico? Something like that. So when it comes out in a burst, we're okay. We can see that the rotate is actually having the effect that we want on an individual scale, but when it fans it, we're getting strange results there. We're getting those super tight rotations. Well, thank you, Colin. Thanks for swinging through. Okay, so Orbit is not playing nice with the radians rotated. So how can we adjust this properly? Because ultimately what we want to have happen is we do want it fanned off, but we don't want it tightening the spiral. And by its nature right now, that's what it's doing. Is by shifting the angle off, we are getting wider or tighter spirals. Which, I mean, ultimately could be considered okay. Let's get our target player going, though. And for our purposes, for testing purposes, let's get our level listing here. Spawn list, yeah. Enemy blob around player. I want to remove the blob so we can watch some of the behavior here. All right, that is never updating its target. That's why. Isn't that intrinsic? Update targets and rotate. Okay. Ah. That should be virtual. Yeah. Fat fingering compile. Okay, so by default, a movement behavior which has targeter, which may have a targeter, it should. If it gets a time passed, it will update that. I mean, alcohol is a a type of toxin or poison, and different people react to it differently. It's the the weird cartoon images of some people getting like bright red noses has its roots in some of those different reactions. Hey, we're doing okay, Nariko. We're doing okay. We're trying to fine tune some logic here. So then we go into our move orbit. Stop handle message. Okay, so this will cause the targeter to be updated when we do this. Well, thank you, Naruko. I appreciate it. There we go. There's the whole thing. Take that. We'll put it in rotate as well. Okay, got that. We should do this with as many of the others as we can. Should get... Uh-oh. Want This is process message. That's going to have caused more problems than I would like to think about. Okay, so this is important. This particular part, this gets the message and is going through and saying like, okay, I get this, I return this. I get this, I return this. Each one of these does its own thing. So we do need this does need to happen this way. So movement behaviors need to call into base, and all of the subsequent ones need to call into base. So we will need to update this. Do I play games on stream, Nariko? Yes. Either later tonight, and if not, then tomorrow. I'm probably going to do another stream of Hitman. We started playing that for the first time earlier this week. And occasionally other games. Trying to get more streams in so that we can get more of that kind of thing in general. Okay. Not handle message, it's process message. So I'll handle message, then we're going to eventually call into process message again, creating an infinite loop of badness. Same thing here. Okay. We are currently testing this orbital motion to see exactly what kind of behavior we're getting, and that behavior is weird. It's not really what we want it to do. Let's make it worse. I mean, it looks neat, but clearly wrong. If for no other reason than that giant cluster still sitting on the feet there. It does look neat when you start moving, though. Okay. So the thing that's not working in this scenario is how we are calculating pretty much everything else off of this. rotation here. I'm just throwing things at the wall at this point. We're just guessing. Okay, same effect. We need to reconsider. We need to consider how to make this operate in general. Hey there, Rocks. Welcome, welcome. We have got our rotational movement going. Now we need to figure out how to make it properly handle being rotated by things like a fan pattern. Now, it's fine if it looks weird, but right now it is thrown off wildly by this. So we can't really apply this to any of the vectors that we currently have directly. Because if we do, we're going to get those super tight circles, as well as the ones that are super wide off course. Again, it's okay if there is obvious like deviation in how they work. But what we need is to be able to control it better. We could impact the radius movement. It will eventually converge back in, though, and that's not really what I want. Like, once it hits its 0 point, then it's then it's fine. Oh. But could we do that? Let's think about that for a minute. Put the dot rotated here. So this is the outward force. Right now, it is a push or a pull directly from the target to the projectile. But if we rotate that, it will shift the pull. It will be slightly off kilter. Let's get a bunch of them here. Okay, we still get some that are right on top of the player there. This guy has come to sit with me and thus is, if he doesn't receive enough attention, will lunge right up into my face. Okay, this seems about right. Because if it's not fanning out, let's just do 1, 2, 3 here. So it's distorted by the random direction motion. But we're getting a definite coil outward. If we fan it, though, we can see some different motion going on. So a couple of things that I think I want to see in our logic here is we need the ability to better control how quickly the orbit is going to go. Let's get the rotate in here as well. It's hard to tell which direction they're actually moving in initially. But that's kind of what we want. Okay, so one thing that we probably want to have is multipliers in the movement. A way to say if what would it be? That this particular instance of it moves faster or slower overall. Now, we can control some of that, but it's not quite the same. So, for example, if in movement behavior, we had another property that was like speed multiplier, that this particular movement type has its movement vector increased. It's what's the terminology here? Its entity movement velocity would increase. It's not really a velocity, it's a direction vector, but it's kind of velocity most of the time. But it would extend that. So each of these velocities would be multiplied by the multiplier so that it would either speed up or slow down accordingly. That would have a dramatic effect on things. And that is a local speed multiplier. It only affects the current one. We don't have any behaviors right now that do it, but we could have ones that change the current speed. So as of right now, the projectile will speed up. So that this and any subsequent behaviors now are going to have a greater speed applied to them. We don't have that yet, but, soon enough. We also need to account for how we're going to do this speed here. Let's put that 2 in here. So, I believe Schmuggums mentioned before where you can get kind of orbital distortions. We're seeing that here. The yarn ball by default, without the orbit, moves in a random direction right now. Since it wants to target an enemy position and move towards that position at the time it got the target. But there are no enemies, so it just goes in a random direction. So when we start orbiting, that force is still at play. So we can see that the orbits are kind of skewed because each one of these yarn balls has a random directional force applied to it. we can remove that for the purposes of like test purity here. It will have weird results if we just straight up remove it, but bullet. So if I just pull this out of here for now. So there isn't like an actual, like, right now, I don't have the elastic gravitation built into orbit. The idea that the force is weaker or stronger at some distance. So there isn't like a gravitation here. It's that the projectile itself tries to move towards a position a certain distance away from its target. So other forces can play with it. So this is, since it has no movement, it just does nothing. So this is rotation without extra forces. See how they all kind of get into the same spot. Hey there, Sam. I'm glad you like the videos. So again, this is without an outside force or any additional force. Now let's toss random direction on there. Now we're going to get akin to what we saw before, where the orbit is kind of ragged now. I want this to work how it's supposed to, but we need to, with the new way that movement works, we need to change. If it's going to change the way that the projectile's like facing or anything like that, it needs to apply a movement vector. The reason that it's not working right now is that the way this one was functioning doesn't do anything right now. Like, that has no impact. Because we haven't done it today. Engage silliness. This type of movement is not cheap. Narco, I'm glad you're enjoying it. Let's let this, if you check my bio or the video description on YouTube, there is a link tree, and that will get you to all of my other channels as well as my Discord there. Letting the change cool off here. So again, this is with no outside force. It steadily gets into its basic circle. And as soon as we apply that outside force, we're going to see it start to distort here. Well, start to is relative. We're getting about 5 frames a second, and there's like 2,000 yarn balls visible. But here we go. Outside force in play. Okay. Just out of curiosity's sake. This is move rotate without an outside force. So it has no directional force applied to it. So it just sort of twirls in place. Which is okay. That's not one that you would normally put by itself. So we're in pretty good shape there. All right, let's look at just the raw orbit. So then we fan it out. And we fan it out again. And again. Let's make another adjustment here. We need a multiplier. 5360, which I don't actually use anywhere else. Okay. In order to make this projectile work properly, it needs to handle spread better. Needs to handle spread better. Because we want to be able to have multiple projectiles fan out around the player and begin rotating cleanly. So orbit still needs work as far as rotated is concerned. So that's the remaining wrinkle that we have here. Because ultimately, it's the initial direction of movement that we need to account for. And it's very likely that there's going to be a distance from the target initially. Now we could apply an initial force to it and have that initial force like a first move, essentially. And that first move have a push to it that is in that direction. Let's do this plus that into here, here, normalized. So we're adding a little bitty force here. Well, it's not really little bitty, but we are twisting the vector a little bit. Well, that's not what it's supposed to do, but it's kind of cool looking. So this isn't right. Early throw that in. I just want to see what it'll do. And that pretty much removes it. So this is without any modifier on it. The fan out does nothing to it at the moment. As we're nowhere are we accounting for this. So I think an initial move is relevant here. Like a very small initial move. So we could have a check. We effectively need a first move kind of concept. where we're going to set the force for that one and alter it based on the rotation. Because that will change where it starts. And if we change where it starts, that alters this equation. Even if this is just a tiny bit that the that center is offset. Ooh. If 0. Okay, if we're rotated. We're going to skew the center a little bit. This changes the center by currently like 1/3 of a pixel. Sorcery. Because the center is off on the circle there, it means when it initially checks its direction, that it's going to effectively have a central rotation there. Hello, car. Welcome. Let's fan it out some more. Yeah. All right, let's add that random direction there. And for those not familiar with the channel, we are one of the things we regularly do is work on our game dev project. We're making a bullet heaven game akin to Vampire Survivors, with the gimmick being kind of modular weaponry. The weapons have a base behavior, and then whatever we socket along with that weapon, it left to right currently, this whole UI is currently, impacts the behaviors. So take the random off here, and we get this nice, relatively orderly spread out here. Then, so this is saying like, okay, in a vacuum, just with the rotation happening, just with it trying to keep up with the player, this is how it behaves. So we get this nice ring, and we can also see the outer edge of the ring distorts to try to keep up with you. So if I keep moving in an arc like this, I can, to some extent, whip the projectiles around. So we get kind of like a gravitation around the player in this case. It doesn't have to be the player, could be a fixed point in the world. I do need to change targeters so that they can point to a spot in the world and say, this is actually what you're looking at. Technically, rotation can do that. If it doesn't receive a entity target, it targets whatever point it is sitting on at that moment. But if we add another force in here, so this is a kind of an equal force in a random direction. Now the orbit is distorted, and the path of the projectiles is distorted. And as we're moving, the cloud is a lot more erratic. Just for funsies. This really emphasizes it. Oof. A cat has jumped off of me. So again, this is with random motion in play. Slowing down quite a bit. Then if we remove the random motion, instead of a chaotic cloud, we get this neat little hypnotic spiral kind of thing going on. And as per tradition, bring it to a crawl. Okay. Let us put down a save spot here. And then I will be right back. Those changes. All right, I'll be back in just a couple minutes. And I'm back. All right. So we actually have orbital motion fixed now. One of the things we'll be doing then is moving back through our logic here for wave and zigzag motion. So right now we're looking at it and saying, oh, our proposed motion is offset in this way. What we need to do is figure out an existing direction and go from there. Second here, there we go. So we want it to be in whatever direction we're given, whatever the current direction is. If it doesn't have a current direction, doesn't have a targeter, it doesn't have a current direction, then it will use a random direction. Sammy has come to sit with me. Typing is inhibited. And we got the... We have 3 cats spread out in a triangle on the bed there. Apparently it's bath time for Sky, and Mason sitting on the folded blanket and Sherbet out in the must blanket. It is weird how adding the unfolded blanket created an area that they like to sit in, but it's still at the corner of the camera where one of the folded blankets would have been. But they have decided they like to sit just on the blanket. I suspect that it not being folded, the surface under it is taking effect, or is more perceptible. As cats like to lay on different surfaces. All right. And as a float. How do we want to do this? Yeah. What do we want to do here? So what we want to do is have a cascading check. It would be useful if we can cycle them out, but okay. So first we check if the targeter exists and has a direction. Move is equal to entity dot get current proposed velocity. Let's check. We should have a targeter for random direction. Take that. Gotta be a cleaner way of going about this. This is our failover, random direction. So whatever direction we're given, whatever direction we're already moving in, or so wave motion is always going to be going in some direction. If we do this, then if it doesn't have a direction, it shouldn't move. Yeah. So what move wave will do is it will use whatever direction it's currently being given for the entity. So this one should never be by itself. Yeah. Zigzag is very similar to this. Nobody to hang out with, Floor? That makes sense. Yeah. Putting buttons on screen isn't always terribly entertaining. Okay. In theory, this will work now. Oh, no, it won't work yet. We should add rotation in here as well. But we'll get to that. Once. Ooh. Semi-rotated. So we've changed this from affecting the current movement to applying a force. This is nice because it's also removing some of the logical variation that we were seeing before as far as how they interacted with the entity's movement. So by themselves, these don't do anything still. But if we apply a random direction, they rocket into infinity. Okay. We need to account for delta. Equals delta. So then we add a random direction and a wave motion. So the star spread is not influencing the targeter properly. Because when that fires, all of its clones should have... all the clones of this should be impacted. But I wonder if that's coincidence that we were seeing before. Yeah. Okay. So this is a 5 spread that moves in a random direction. So it's initially spread into 5, but the rotation that applies does not impact this movement because this hasn't happened yet. So it doesn't have any sort of thing to rotate. That is technically a flaw in this because you rotate entities. You don't rotate behaviors. And we can tell how to make that work. Let's put down a change here. Clear some of these. This in sequence. Through. Okay. So the problem that we've got there is for our random direction. Right now, the default with targeters is that upon getting a rotation, it applies it to the direction. But that's not necessarily correct. Whenever we update, that might override what we just did. We're gonna clean up some stuff here. Direction X and Y are here entirely for JSON purposes. I don't know how you format a vector 2 in JSON. Such is life. So we have our entity. Don't need to keep doing these cast operations, even if the compiler cleans that up in the background, which isn't out of the question. We may need to change a whole bunch of targeters as a result of doing this, but that's okay. Most of them were just direction anyway. Okay, so what we're saying here is that if we have a direction, we are always going to emit a direction rotated according to what our current rotation is. So when that rotation came through, it would have rippled through every behavior. This is interesting. We're going to leave that one as is, because if the rotation happens, this is saying whatever the entity is targeting, you're targeting. In theory, that means that whatever the entity's target is the result of something else that would have, if rotated, if it were to be rotated, it will have been rotated. If that makes sense. Entity dot get dot rotated dot normalized. Hey, Kazuto, welcome, welcome. Okay, that's rotated. Now, alternately, we could have behaviors handle the rotation instead of having targeters do it. Because as it stands, some behaviors have to deal with rotation in their own way. And this would just double it up. Well, let's see what happens anyway. Random direction into a wave pattern. Oh, wow, that is messy. Okay, yes, so here's our problem. It's the movement of each one is like each pattern is accounting for the rotation. So if I cut this one out, do this and this. Oh, it's wrong rotation. No. I'm going to be right back. We'll do our break a little bit early, and we will try to figure out what's going wrong. On the back. Here. There we go. Okay. So let's get random direction going and see. Okay, random direction is still not rotating as expected. We got rotation largely working how we wanted it to, Schmuggums. We're moving on to getting wave motion and zigzag motion updated. At the moment, what we're trying to do, Kazuto, is we're updating things to a new movement pattern that better blends the motions together and also gives us a lot more control. But after getting rotation working, like orbiting or circling kind of as it moves, I've discovered that the raw act of rotating the entity, which is part of doing things like firing in a starburst pattern kind of thing, isn't doing what it's supposed to do. There's no rotation in here. A thought. No, radiance rotated is carried. Um, it kind of varies, Schmuggums. There are libraries that can streamline some things. Um, Sometimes you don't use them because you don't want to include that particular outside code base. Um, it can create problematic reliances. Uh, for example, I'm using JSON data loading. There's a library that used to be completely ubiquitous. It was what people used for JSON, and it was Newtonsoft JSON. They have stopped supporting that. It is a security liability to keep using it. So everybody using it suddenly has to jump ship onto something else. So I'm using the Microsoft default one, which has some idiosyncrasies that I had to overcome compared to what was used before. But other times there are things that you can absolutely make work how you want, all without any changes. But yes. Okay. Triggers each behavior, and each behavior rotates its targeter as needed. And then when we target direction, 0. Should be all of them should have a rotation, except one. Oh. I will say, and maybe you've encountered it, but a very large part of the process for programming is um, staring through the screen into the middle distance, trying to figure out why it's not doing what you think it should be doing, until you figure out that you weren't telling it to do what you think it should be doing. Okay, so the sequence is we go in, and the first action that the yarn ball takes is to trigger the split into 5. That will create duplicates of it that should all have their rotations set. That should have propagated throughout the entirety of the projectile. So all of its current behaviors got their rotation set. Because again, if we throw this before, we still have a wild scatter shot here. If we throw this after, we have little clusters of 3 stacked on top of each other. Now, they shouldn't be stacked on top of each other. That's still a problem. Probably some of that. Additionally, my eyes aren't great for the tracking. Just kind of the nature of the shape of my eyes. So it means that small eye motions can result in a lot of blinking because I have scripts in the background that translate some of the small motions of one eye into a double blink, so that I don't get like weird little flickers of one eye or the other kind of stuff. Similar with my mouth. I have set up additional tracking for my mouth because it seems to have problems catching small motions with the way that I talk. If So when this is duplicated, it should be a copy of whatever the other rotation directions were. This is code that's been around quite a bit compared to some of the other stuff. Haven't touched it in a while, and it is overdue for it. Well, thank you, Kasuto. Don't know if you've ever seen it, but there you go. There's the entirety of it. And because we all like to show off sometimes. Okay, so it is splitting before random direction kicks in. Before this gets called, which means the random is applied after the split happens. I do like how well the artist did with this. It is something you see a lot of stories of artists having trouble with people commissioning them. And I wanted to make sure that they knew what I was looking for up front, that we had a lot of details, so there wasn't any like I'm springing something on the artist out of nowhere because I just remembered I forgot to say an important detail. So I had a spec sheet, maybe, you know, kind of like PowerPoint presentation level phrasings and whatnot that was about, let's say, a page or so, a little more with sample imagery, that kind of thing. And they were surprised that I gave them so much detail, and it was one of those things that in the back of my mind I'm saying, what are other people subjecting you to if you're trying to make a live 2D model and they're not giving you much detail? And on top of that, this is above and beyond the detail I gave them. Like, there's a lot of things that they came up with themselves. I don't understand that. Isn't it able to make both actions active at the same time? What are you referring to, Casto? Okay. Is this how we want it to work? That if it splits before it has a direction, that it applies the direction then. I think yes. I declare yes, because I don't want to have to try to deal with it otherwise. Effectively, Kasato, they're all kind of happening. They're happening in the same moment in time, but they happen sequentially. That is not an uncommon sentiment, Schmuckums. Okay, so we're going to add movement fixed right. Gonna put that on the bullet. Yep. Hello, Sky. Hello. Hello. I'd mentioned before, if Sky doesn't get the attention he wants when he's on my lap, he will climb up my chest and headbutt me. He gets real insistent. Yes, he does. I'm trying to think how old Sky is at this point. He's still under 2 digits, you know? I think. Pretty sure. But he is the oldest of them. He's still a troublemaker, but he's settled a lot. In context, that's not much, but his troublemaking has definitely been overshadowed by Molly's, but he is still mischief. He's also my biggest cable chewer still. Okay, so... Well, thank you for the super chat, Kasuto. Still throws me off. I have a sound message that plays in my headphones. Shockingly, in my headphones. Whenever there's an alert. I see it popped up properly. Took it a moment. It is just me telling myself there's an alert because there's no, like, audio signal otherwise. I might just have to change it to like a ping sound or something. But regardless, yes, I am petting Sky as we speak, Gusto. He demands attention. He was causing trouble earlier today. Sometimes he wants chin scratches, so he'll sit right next to my mouse hand. And if I don't stop, he'll reach out and he'll grab the mouse. And he grabs it in such a way that it will click. He seems to recognize that that's one of the best ways to get attention. Okay, so it's going to move right before it splits into 5. This gives it an existing direction first for the split. Now, the randomization is still going to happen after. But we should see a... Well, we should see it not work at all. Okay. As it starts moving right... So the very first target direction is from a yarn ball. And it has no direction at all. That shouldn't be possible. It's a movement fixed right. This one doesn't have any special values. So when a targeter is copied, it should copy each of these. So we're updating the direction. I'm located in the US, Costo. I don't know if that's the specificity you were looking for. But the audience for my channel has tended to be frequently international, so it can help to at least specify, you know, continent. Direction X and Y need to be specified. Targeter fixed right, so we need to open up our targeters collection. Oh, well, see, that would do it. You see how these have cool names that imply that they're directional? And that it's got a class that implies it's directional, and then it has no values that say that it'll be directional? The down is 0, 1. If you're curious, spatial coordinates in Godot world, negative is left and up, positive is right and down. Huh. That's just classic. But this is one of the traps that you can easily get into is anthropomorphizing code. It's not what the code wants to do. It's precisely what you told it to do. Well, it's still not working, but entirely, but you can see that it is moving to the right. Since there's no further motion, it's just going to the right, because the starburst happens after this movement. But it should still be offset. It's treating it like it's an absolute here. This is closer. It's still wrong. Did I mess up multipliers somehow? Calling rotate with an increment on it. And that rotate will affect all behaviors within the entity. And we keep our existing rotation. We keep our existing direction and we rotate it. So if I start So we're going to immediately do this because it fires the first one at 1 second. If I stop it right away, then we'll get to see here. So the first one fires. It's moving to the right. That is correct. Its radians rotated is 0. The next one that triggers... I'm sorry, there should be 5 that trigger next. So, okay, we have a 0. How is that possible? We have radians, but we had a 0. We shouldn't be able to get a direction of 0. So we should also have move straight line. Let's open that up too. Ah. We need to make sure that we update target each time. One, 0 again. Oh, it's the explosion. Okay. Okay, that's still wrong, but we're getting closer. It is fixed right. It is 1, 0. So this is the first one. It says to the right. This is the explosion. Ah. Okay. Wrinkle. So this has a direction, which is what everything is going to read. This is telling the entity, as of right now, this is the target direction. This can be useful. I don't know that we're actively using this really anymore. This should be replaced with the proposed movement direction. But it's going to ask about this. This is either set on creation or it's set right here. Direction. we are setting the entity to the rotated one, but that's not the actual one that we're going to be reading. We need to change direction. But to do that, we need to keep the original direction around. So anytime we change direction, we also need to we need to store the original direction, essentially. So after we have copied, for the purposes of this one, protected vector 2 original direction. Don't need to do this, and I keep saying that, but we JSON ignore since it's not a property. It's not going to be picked up on by JSON, but just in case. In code, it's better to be pedantic than it is to miss something. So we call the base, we do the base, we store off the original. Okay. So upon creation, we say that whatever the direction was, we're going to keep that. We're going to remember it. If we get to here and it's 0, there was no original direction, we randomize it. At all other times, we set the current direction equal to the rotated original direction. And we update the entity according to that as well. Ta-da! The one moving to the right is the original. The other 4 are copies. This is still wrong, but it's wrong closer to right. Why would this happen? Because the one moving directly to the right is okay. It's the subsequent ones that are a problem right now. as this should be getting an offset in here. Well, thanks for swinging through, Costo, and thank you again for the super chat. Okay, so this is the base one. Anytime it's 1-0 down here, which is probably hard to see, that's the original. And then all the subsequent ones all the subsequent ones have direction based on their rotation from the base. Wait a minute. Thank you, Schmuggums, and thank you for joining us. Okay, proposed direction. Because this rotates it again. Okay, let's... Proposed direction is dependent on a prior targeter. If there isn't already motion, proposed direction does nothing. If we rotate proposed direction, we double rotate. And that's what was causing it. I wonder. Nice. Let's make more of them. So the wave motion is subtle here, but it's present. Let's double check with this one. This will be much more erratic. At least it should be. Let's remove the spiral just to see. Okay, well that one's clearly not working at all, so we need to check zigzag now. So whatever its proposed direction is. Oh, but it's really subtle now is the problem. We need to exaggerate this more. We need to spend longer within this because we're not... We could change the way we're doing the calculation. We could. But I want to be cautious of that. Effectively, we could do kind of what we're doing with rotation. and orbit is instead of taking a vector and kind of pointing it, we could do multiple separate ones and multiply them out. But I think that's what we're going to want to do here anyway. We can make it take longer with the cycles. So if we look at wave, we have cycles per second, that kind of thing. And how long it lasts on that. So if we say it goes for 2 seconds and cycles per second is 0.1. I want to be able to adjust this differently. This was effective when we were just twisting the existing movement, but it's less effective now. So this is, it has 2 full seconds of time spent in its arc. And similarly, I'm sorry, it takes 10 seconds to change direction. This one is supposed to take 2 seconds before it shifts, but it's not. So zigzag's still broken. So velocity of 0. 0, 0. That's why. Hey, stop. Process message. Wonder if there's an easier way to get this going. Where I always want to do this, but for now. It's just such a easy point of failure in the code that it concerns me. So for zigzag, I think both the sine wave and the zigzag, I think, need some new logic. So both of them, I would like to have essentially a better way of determining frequency and amplitude. Amplitude we can't really fully control because of the speed being something we can't fully control. Yeah, we are technically doing everything that is currently available to us. It's the more cycles per second, the higher the frequency of it. The faster it moves, the greater the amplitude that results. If we add in a force multiplier to it, then, okay, we should be able to do this. thought it allowed us to do live debugging, but it do not. Okay, so we're going to heavily exaggerate the movement that results from the zigzag pattern. That's still not what we want to do. Because this is just make it go faster. Now, this is technically another way that something can operate here. Now, wouldn't this do the same thing? Not really. This is not speeding it up times 5. This is giving. This is taking the same bit of movement, and instead of it getting 1 share out of 2, it gets 5 shares out of 6 as far as how movement is determined. So this movement has a greater strength as far as the velocity, as opposed to the moving to the right. So we get bigger and bigger corners to a limit. There's only so much that doing this can do perceptibly. Because again, we're moving in tiny fractions. But yeah, after a bit, there's not really a big difference. But then we go back to normal here. You can see it's shallower now. So to really make this make a difference, there are 2 aspects that we would need to mess with for zigzag, and that's how sharp the angle is, how much left and right. Right now it's defaulting to 45. So there is a change, but it's not dramatic. If we... So we don't want 90, we don't want it to snap up, down, up, down. But if we do like 60... Still not a big difference. It's only 15%. Just for giggles. Now see, noteworthy, this is the one that's moving to the right. With the wave pattern, we have logic that is in place to make sure that the straight line, which is, you can see this place where it's kind of doubled up, the seam of the bricks there, that is a straight line to the right. This is always going down because it snaps 90 degrees down and then back up each time. So we're getting it kind of twisted off, so it's a little below where you might want it to be. We could adjust that with the cycle starting at half. Like offset it a little bit in. That should have covered it, though. But why? Okay, with 45 degrees, we have the same issue. It's coming out initially, and we bank it down that much, and then as the same amount of time, we need to tick it back sooner than that. Let's this right. This isn't the right way to do it. What's going on? Zigzagger. Cycle duration is 2. Let's walk through the logic here. So every full cycle, this should have done it. By starting at the halfway point, we should toggle back sooner. So if current cycle is at 1 out of 2, every time we're adding delta, the next time we cut back around. So if we hit our cycle duration of 2, we switch. And then we truncate back down to a cycle duration that is shorter than what we have. So this handles spillover time, I guess is what we're saying, is we cut it down to the remainder. We could do this with some division. Okay, so since we only have the 1, the first time we enter this, we should see a 1 in current cycle. But it's 0. Because we never call set cycle duration. So the first time it operates, the very first time, we need to do this once. So we're going to add another little property in here. So not initialized, then set if it's the first cycle. There we go. Subtle difference, but now the center line of the zigzag is following the path that it originally would have gone. I want these movements to be more emphatic, though. Like, I would like it to be sharper. So what we want to be able to do is accentuate the angle. Or at least stretch it, you know? So again, now if we look at it and say it's 90, hey, Calamity. We are moving along. Okay. We just need a sharper angle on it is all. Today we've been getting our rotational logic. We got our rotational logic fixed. We are updating so far the sort of oscillating motion to match the new model. This is an orbit around the player mixed with a 90-degree zigzag pattern. So there's almost, you can almost see like a polygon forming here. There's almost like a, is that a pentagon? Looks like there's a pentagon forming. Let's see, if we thicken it up, do we see that? Or does it distort it into a full circle? Distorts it into a circle. Okay. It's more visible when there are fewer of them. As we can see, kind of, yeah, it is kind of a rotating edge shape. How long have I been working on the game? Let's see. I think this is the 138th stream we've been doing. So quite a while. I don't know when the first one was. We're not moving at the pace I would really like on it, so to some extent trying to accelerate a bit here. No small portion of it is because of the design decision, or at least the core gameplay decisions that have been made leading into this greatly increase the complexity of things that in other games of this type wouldn't have been an issue. Okay, so how long does it stay that way? We're going to cast that to a float each time. We'll just remove this. Okay, so now we set angle in here. And we go into our movement so that we can mess with it here. Let's see, we don't want it to be 180. Let's make it real sharp here. Doesn't seem right. Oh. Angle. Degrees to radians is not an expensive operation, but why do it extra times? Oh. Yeah, that is a sharp angle it's moving at, so it's moving extra slow as a result. Then if we throw orbit in there, so we have less impact from that. Because it's sharper, it slows it down over the course of that. Now, one thing I could do is accelerate it accordingly. So this is it rotated based on which direction we're going. Compared to its original velocity, we now have a difference in distance. So, second here. We don't need to blind everybody outright. Okay. So over the course of it, every time we oscillate, we're changing the direction into something like this. And in fact, it's more... it's not quite this. It's not that at all. Let's just freehand that in. Okay, so it's more like this. Sorry, we would have crossed this much linear distance, but instead we have now only crossed this much distance. Distance on the ground, like the path, has not changed. So this part of the line is the same length as that part of the line. We've just rotated it. But because we've rotated it, the distance that it was going to move has now shortened. So what we want to figure out is, can we extend this such that we instead get here? That's a weird feature paint. What we want to do is extend it by that much. Which will mean that we still cross the same distance on the ground in a straight line, but now we've created that zigzag pattern on it. The projectile has technically sped up. The advantage here is that it changes it from being something that serves to increase coverage in one direction at the expense of something else into something that is changing the coverage of the projectile potentially for the positive. So like a high amplitude wave can increase the amount of space that a projectile will cover. It can still miss, but if it's moving fast enough up and down, then we can get greater coverage. Space that the ball might run into, you know? While we're thinking about that, we're going to step away for just a moment, and we'll continue after. And I'm back. Okay. So again, what we want to figure out is what our linear distance when we are, like in this case, if we're moving to the left, if we rotate it up, the distance moving to the left, the distance along the original path has been truncated. Which is not that one. We want this one. We want to add, I'm sorry, we want this much more space. And because of that, we need this much more, which is longer. To account for green, the space that we have lost, we want to add purple, which will make up for it there. But we need to figure out how to calculate that. I don't know where any of these links are going to end up being. We know, okay, we would know this length, and we know this length. Those are the same. Actually, I've already got a marker for that. We know the red length. That is pre-existing. Well, kind of. Making this harder than we need to. Okay, so we can assume a couple of things going in. We know that that's effectively 1. That whole distance is how we're going to treat it. That's how we're treating it. So red is 1. Because we know that, we now know that part, and we know the angle here. Does that help us? Oh, there's geometry and trigonometry looming here, and I've forgotten to some extent actively, if not just willingly, almost all of that. Just a moment. Hey there, Lunar. Did I add a Black Friday shopping minigame yet? That is likely going to be a thing. That is almost certainly going to be a thing or referenced in some fashion. Cleaning my eyes off here a moment. There we go. Oh. Doing some quick reading here to see if I can find So again, what we're looking at here. Hey, Dorothea. I need to accelerate this in proportion to the angle. So if the angle is greater, then I will be cutting more and more of the linear distance off. This is not accurate, but effectively. So there's a great deal of truncation here as a result. So I would need to extend that that much more. But how do I identify that change? And hello, Annabella. Welcome, everyone. Math. Is there a good way for me to figure out is I can get the offset between the two. Okay. Okay, so we are going to we've got our little rotation that happens. Wonder if we can do this way. No. Nope. No. Freehand it is. Okay, so we have these two. We have an offset between them, like that, which should give us a right angle here. And this length is known, and this length is known. All of these are known. But what does this give us? Again, not to scale or anything like that. If we know this one and we get the offset, we now have we have a third known point here, and that's what that would be. Now, if this was just like on a graph, like if this were left right only, it becomes more straightforward, but it's not. We could do that. We could force it by starting with a given angle and rotating it to the angle of whatever our relevant points are once we've got it. And once we've got this, we have a known offset. No matter what, given the way the algorithm works, once we know, like, we could start with this and we could calculate this whole mess. So let's assume it always goes left right. This is, again, each of these is 1. Because we've got that and we've got a plane on it now, when we rotated this up in whatever direction, we have a y vector here. So we'll muddy this up even further. We have that. So this is our y offset here. And we have an x and a y. The y we don't care about when this is, but we care about the x here. Once we have that, we have our difference here. And then we apply that difference here. Yes, because if we do the exact same math on a plane, it doesn't matter what this particular vector starts as. What we're going to do is universally true. Yes, okay. This gets way more complicated on the sine wave. Oh. Okay. We know what angle is. We know what the radians of rotation is. Uh, so if our base angle is 1, we are using a unit direction here. Direction should always be a unit vector. I'll figure out how I need to do that if I need to change it to ensure that. But this is length 1. So that is the maximum speed we could go. We will always adjust that by delta at the end. Say base. Not an offset either. Let's call you vector. Okay, now we have vector 2 right rotated in this way. The x coordinate is the relevant one now. Okay, so this is how much extra length needs to be added to account for that rotation. As we know that it's supposed to be a length of 1, then I mean, this is the equivalent of 2 minus, but okay. So we are stretching it out based on this. Again, this vector is 1 long. And if we rotate it, we are going to get effectively the x will contract. The y will extend up or down, the x will contract. We take the absolute value of it just to be sure that we don't get some weird negative shenanigans. Still possible. But now we have a 1 point something that we are going to extend it by. So we are going to accelerate the projectile along its zigzag path in order to speed it up, or to make it keep pace along its original path. That's not working. That's not working at all. That doesn't make sense. Why would this... Okay, maybe... Okay, here's 45 degrees. I think it was the angle that we were operating at. Okay. Stopping there. So it's stopping at the start of the third gray block. Okay, it's not going to be perfect in that regard because the speed isn't just this. The linear speed is affected by this no matter what. We're only changing it so that the speed of the particular operation is different. That is, the velocity that we're adding more velocity to account for the angle change. But because this is moving right, it's moving right at a rate of 1 square per second. Only half of that 1 square per second happens now because we're also doing zigzag motion. We're trying to preserve that same thing, though, so it feels like we're off a little bit. Seems like it should be right. Rotated vector here. Yep, that makes sense for about 45 degrees. So we should be getting kind of a 1.3 sort of dealy. Yeah. Oh no, 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 no. We're not done yet. We're not done yet. This is not accurate. It's this. In order to cross orange, we need dark blue, which is a different thing. So we know what orange is, but that's just the original length. We know what this angle is. So let me... Oh. Using a triangle calculator site. So. All right, so we know this whole thing is 1. If we know this is 1, I'd like to figure out what the algorithm is, but let's say this is 45, so it's a full right triangle. We know this is 1. That means we know this is 1. We know the whole length of this. We need to get the algorithm to say, okay, given this length and this angle, what is the length of this, and thus what is the length of that? Because then the whole length of that is the multiplier. So let's see here. This did have the math on it. Sorta. Length of C should be the length of the known one. So the length of the hypotenuse here should be the length of the known side over the cosine of the angle. Let's find out. Hypotenuse, isn't it? The long side. So it's going to be offset multiplier is equal to 1 divided by and takes radians, right? Yes. We're going to do, just in case. Let's just see if this works. I'll be just fine if it works. Okay, it gets off the screen. It's currently operating at what? 45. Start it again. Does it get off the screen? Oh, no, it just breaks. Oh, this isn't quite right. Yeah. Still doesn't seem quite right. Okay, this is without any change. Makes it the whole way up. Sure that that's float math. Well, it's definitely float math. We're going to move 0.41 times faster, 41% faster out of this. But we're definitely not moving fast enough to offset it entirely. And every bit of motion that we add on top is just going to exacerbate that. Well, that's not a good indicator. I need a just continue variable added in. This should preserve a linear velocity. This velocity should be the same, because I have one coming in. So it's about 1 second per. Yeah, this is moving at about half speed. We have two different vectors, but if I'm preserving linear speed by doing this, then why are we slowing down by like half? Means we're probably not accounting for something properly here. This isn't length 1. Even rotated, that's not right. Targeter proposed direction gets it normalized. Hello, Drac. Wasn't there somebody calling out like a trend to change their profile picture to Clippy? I don't know why, but I saw somebody mentioning that people should. Why would it? That makes sense. Okay. We are moving to the right. And we are going to rotate it. Okay, no, that's still one long. This is a Vampire Survivor style game where weapon upgrades come in the form of kind of sequential modules. So each thing that you slot alters the movement in some of the behaviors of the weapon instead of it being fixed upgrades. We are currently working on kind of an oscillating style motion, and I'm trying to figure out why math wrong. Okay, it is now a greater length. We are now going 41% faster for this particular one. It will be offset by delta, but we have extended this particular one to be 1.41 long instead of 1. Sort of. let me just let this go here. So for our test case right now, these aren't like end products or anything like that. So it bugs me. Why is it going half as fast as it should? Anyway. So moving in 5 directions. Its focus direction is to the right. So that's the way it's firing right now. If we add a wave pattern to it, now all of them will move in a wave pattern. These are not actual upgrades. These are like small pieces of upgrades. We're just getting the smallest pieces made here. If instead, here's the kind of metronome tick that we added that we're working on here. It's going way slower than it should. So it annoys me so. Now it'll fire in clusters of 3 after splitting into 5. So we can see the central cluster of 3 here. Then let's make them orbit. And they'll follow the player like this. If you've ever heard of a game called Noida, that's the reason we're doing this. That used to be a big thing on this channel. Let's throw a random direction in there, make it real messy. And we'll put that there. But each of these movement types can kind of socket on top of each other, and they're processed left to right. That can have consequences that you might not realize with some of the motion. So, like, orbiting after wave pattern is going to be a little different than wave pattern after orbiting. So let's reduce the number of them so it'll be more apparent. So again, this is wave pattern. It emits in a 5-star. Then it goes in a wave. Then it goes into the orbiting logic. So let's swap that and see how much of a difference we get. It won't be a lot, but some of them can be noticeably different as far as how they play into it. The end result of the vectors in this case should be the same, but some of them are going to throw it off. Right, Drac. So the goal is, like, the yarn ball is not doing what it's supposed to long term. But the goal is that having picked this weapon and having been presented with these upgrades, what can you make of it? We've been doing a lot of performance testing on this because while we don't want it to be easy to go out of control, we want the player to be able to find combos that just wreck the whole game. That it's just a I win now effect. Like, would this ever really happen in the game? No. Like, this very particular thing, no. But could you get a similar effect? Yes. Not that one. It's this one. I wonder how much we can strain the game. This is actually going to be a lot worse than anything we've done to it recently, because we're starting from ×5. So we're starting from ×5. We fire each of those 5 fires 3 in quick succession. This is all once per second. Each of those splits into 3, then splits into 3, then splits into 3. So we have 405 per second. Each of those lasts about 10 seconds, and every second it creates a particle effect. Each visual frame or so, might be physics frame, but every so often we update the number of things that exist in the world. It won't be perfect because those explosions only exist for about a 60th of a second as far as things. Right now there's about 3,800 things. We're getting less than 1 frame a second, but it's set up to not allow for fractions. But the game is still functioning. I'm holding to the left right now. It's still about 1 frame a second. We're not quite, but we're getting at least 1 every other second. But the player is moving to the left. And now the explosions will roll a little to the left. But, so we stop. I do need to figure out a way to make it so that the animations stop gracefully. It might just be a matter of having a better pause flag. Anyway, so now we're going to remove that so that they stop exploding. And we'll remove one of these to tune it down and put that in there. So it's going to take a moment for all the ones that explode to go away. I don't know that real-time editing will be a thing. Again, in a similar vein to Noida, one of the things is when you make your choices to be careful about what those choices are at the moment, because they can have long-term repercussions. So there's still going to be a lot on the screen, but we should get back well into frames per second. So now we're back to about 1,300 things. For reference, games like Vampire Survivors, about 700 things is about the maximum that you would expect. And that can start to get choppy. Not super choppy, but it can start to get busy. And if you do the enemies. So if we look at about like 1,000 things being associated maximum, we don't perform as well, but the algorithms for moving things around and similar are much more complicated as far as what we're going to be doing. But if we cut down a little more here, the kind of around 700 is kind of a sweet spot. Like right here, we have excess frames per second. We got plenty. It will take a moment for it to get back to its maximum. There's a lot of like memory and whatnot that has been allocated to account for that. You know, we had 3 to 4,000 things active at once. Such that if we start fresh, we're sitting at over 1,000 frames, physics frames processed here. Well, that's visual frames, but they get impacted by physics frames pretty steadily. So we're going to try to get back up to our 400 or so. We're using Godot engine, currently 4.4, and we're doing all the coding in C#. We are not using baked-in physics or navigation or anything like that. The cost of that is too high for what we're doing. There's a whole lot of basic physics simulation that we don't really want. I do like it. The cost of entry, both monetarily and skill-wise for Godot, is actually pretty low. It's very easy to get in there and just start messing around with the built-in GD script language. And like most engines, it has enough tools for you to make things like basic platformers really easily. Like, what you see during these dev streams is not... This is not a good starting point. It's not a good starting point at all, but, you know, we went for the deep end. I wanted to do this. Having, prior experience programming helps. But this is my first encounter with Godot, first game project in general, first time doing extensive coding in C#, but the C# thing isn't really a hurdle at all. If you know one programming language, it's fast to learn another. Okay, why this no work? Yeah, for example, just throwing it out there as far as like platforming, again, and this isn't like unique to Godot, but in Godot terms, there's things like kinematic body 2D, which is a physics simulation of like a player object. So all of the running, jumping, sliding on things, all of that can be simulated in the engine without you having to do precise motion. You can just say, hey, they're moving to the right, accelerate them this much. You can set gravity, friction, all that kind of stuff. So a lot of that is kind of available for you to play with by default. This is the length of the far side of it, assuming that we have a 1. I'm working solo. All the graphics are things that I have cooked up myself. That's not like one of my core skills, but it's fun to learn. A non-trivial amount of this is derived from, well, I like working in sprites both because it's simple and because that's kind of the sort of game art that I grew up with, so it's got kind of a special place, you know? I like working with small pixel art frames. Again, I don't do it because I think that it's like, oh, it's going to be like a Game Boy game. But it's more, there's something to be said for trying to convey as much information as you can as much information as you can with a limited amount of data to do it. Now, it's not to say there's no artistry in like super photorealism. You can do awesome stuff with advanced graphics. But I think there's interest in taking, like, my smallest sprite, like where I started was 16 by 16, is can I fully convey shape and behavior and potentially personality with just a little bit? And people have done that with less. Hello, Steerbo. Welcome. I believe there's a game where all of the graphics are like flat color polygons, and the player character, the your means of interacting in the world, is like a rectangle, and they still manage to convey some personality, some behavior in that. So it's a fun exercise there, because if you use something that's fantastically photorealistic, but it doesn't convey what you're trying to make it convey, then you failed. Doesn't matter that it's super shiny. All right, Drac, thanks for swinging through. Steerbo, we're making a game. We're making a Bullet Heaven Vampire Survivors style game, and we're trying to make motion very modular. So, I can kind of put things together as I see fit, and we get different results based on what I do. In the background, all of this stuff is happening linearly once a second. Exactly, Steerbo. That's the inspiration for that. We used to play a great deal of Noida on this channel. We had like a mod we made with the community, all kinds of fun stuff. We played that to death, and we shall not ever again. But the spirit of the mod lives on. And some of the art and, frankly, a great deal of the channel lore comes from that. But that is the goal, is that when you pick a weapon, you're just picking the base of what you're going to do. So kind of a combo of wand and a starter spell in Noida terms. And then everything after that is going to be like modifiers. Make it go fast, make it move this way, make it punch through things, make it bounce off of stuff. We don't have the enemies active right now just because, but let's turn them back on. There we go. So we got the little bouncy guys coming in. They are a creature that we will be using in the actual game. They are not an actual starter creature in the actual game. But we can see that was a straight line that was a starburst of 5 that was always point aligned to the right. This is that same starburst, but set to rotate around the player at a distance of about 2 squares. About 192 world units. So that one change there turns it from a weapon that isn't terribly effective into one that is very effective. Now, bouncing we can't see terribly clearly here, but we can rotate out, which does give us more coverage. And you can also see the bouncing behavior of the yarn balls better this way. They can still get in. There are little gaps in the star here. But what if we make it weirder here? They don't quite play with each other properly. Actually. But this is a lot of the process with this one, is figuring out how to make them combined. Okay, we can see some of the variation caused by that. It's subtle because of the way the rotation happens. But the reason, part of it is the subtleness of this interaction is because we're dealing with kind of atomic units. You would not have a power-up that is just orbit the player. Because that's much more like an intrinsic behavior of a weapon. But something that says, well, this now pierces enemies and it makes the projectile move faster, or it makes it blow up on impact. Or in this case, it consumes the next weapon and turns it into an effect on this weapon. I don't know that we'll see it because of the nature of the yarn ball is such that it reflects off of one target, but you should see some explosions happen now and again. In the test code, a yarn ball can kill a blob in one hit, and since it can bounce, it will live through that one, the first hit. So it has to hit 2 blobs before it will explode. But you can see the little explosions going off. This is another one that won't happen in the form that it is, but for testing purposes, this is consume the next weapon and make it fire every second. So, in Noida terms, this is getting into your LARPA territory, where the weapon becomes fantastically powerful if you can use it. And cost of super powerful things isn't something that we're considering just yet. That is definitely a down-the-road kind of refinement territory. Like, does the weapon fire slower? Does it in some way, is it in some other way limited as a result of using this combo? Our goal is to make fewer things that are bad. Noida was kind of plagued with upgrades that were just bad. So we want to avoid as many of those as possible. Even if it's not the best thing to get, everything should feel like, oh, but that would be cool if, kind of thing. Yes, all of the saw blades. Yep. I want to hit that kind of sweet spot with this kind of game where it's okay for you to know a bunch of upgrades and say, boy, it would be great if I got this upgrade. But I want to get a couple of things to go away from that. Is one, I want there to be so many options that hoping for any given combination is largely not useful to you, because RNG says you're probably not going to find them, or at least the combination that you want, or that you're thinking of. And the other is that it should feel compelling for you to make use of the choices that you have. You might look at that and say, well, that's not going to be optimal. But every one of them, if put together, should feel as if you have upgraded it. you might need a coverage weapon like this, but what you got could still be a fantastic single target weapon. So again, if I take the rotation off, I now have a fixed path of explosives. That's still pretty effective. I'm still covering a lot of ground, but I've got these weak spots in the defense. Since I have fixed directions, though, if I move around, I can still have a lot of coverage because I know exactly where the projectiles are coming out. And that's the sort of calculation that we want the player making is, okay, I have these options. Which one works best for me right now? But yeah, a lot of the engine that we've got, I mean, we're not anywhere remotely like Noida level as far as custom engine, but a lot of the ways that we are choosing to put things on the screen and interact with them has had to be custom because we can't rely on Godot to do everything that we're doing and be efficient about it. There's extra footwork that we're putting in. But it also means we get to learn a lot of how to do that extra footwork. And we've explored fantastically complicated things that we've decided we're not going to do. Because the flexibility that we lost was not worth the gain that we were getting. But we are very concerned about performance in it. One of our jokes with the Noida gameplay was our goal became, how hard can we hit Colmy at the end? It wasn't, can I go to other dimensions? It wasn't, can I do the world exploration things that others have already solved? It was, can I get to the bottom despite the viewers trying to kill me? And can we hit Colmy so hard that he is super dead in one shot? And as a secondary, can we do it without crashing the game? And that is assuming extra performance modifications that I made in order to reduce the chance that we crash the game. I think one of our best instances where the game did not crash was something like, it was like, what, 3 to 5 minutes per frame? And the damage number was in the quintillions. So we want to make sure that the performance of the game holds out as well as possible at ridiculous situations like this. This is what I often refer to as a calamity case. This is either some situation in the game or a choice the player has made in general has reached a point where the game is stretched to its limits. I want to be able to handle that because it is very cool when you get a weapon that does this. And it's okay because the player wins. You just win. I don't need to balance for this. If you manage to achieve this, you win. Round over. Good for you. But this shows you also how much calculation is going on. Just rendering the things on screen. There's a lot of Godot objects on screen. And we have about 4,000 things in the world. Each of those things accounting for 2 animated entities, the ground shadow and the sprite itself. So like this bouncing blob under the light, the life bar here is the blob, its ground shadow, its collision area. And so we have, but we're not counting all of those different parts. We're only counting there's a blob. So remember that this 4,000 is actually more like 12,000. So we're sitting here just looking at these things at 40. We resume moving, and we drop back down because now all of those things, every physics frame, are doing stuff. This is more in line with a calamity case, frankly. There is no escaping this. Doesn't matter how many enemies, it doesn't matter if they take more than one hit to kill. There is plenty more than one hit per screen real estate to be found. And we're still running at more than 1 frame per second, which means we can make it worse and worse. I've only blue screened the stream once. Twice if you count within an hour after the stream. But that was when we were messing with compute shaders, so that hardly counts. We're looking at about half to a third of a frame per second right now. I do really need to see if we can get that fractional. I don't know if that'll do fractional. Well, no, actually it will do fractional. We just need to constrain it per digits. But with this, the game is still running. If this situation were to arise in the game, it's fine that it takes forever for it to play out. And just like in most of this kind of many entries in this genre, it is not about lasting forever. It is about getting to the end of the level. Beating the boss, hitting the time limit, something like that. And if you have this weapon, this expanding blob of doom, gives me kind of an idea for something that we should include in the game. But if you actually achieve this expanding blob of doom, you win. And that's good. Oh, wow. We're over 10,000. We're nearing the end of the evening, so I figure, hey, let's do a stress test. If you look close, you can still see the ears of the catbot sticking out of the center of the mass. Based on which frame of the animation he's in and what the explosion particles around him are doing, sometimes the ears will peek out. Wow. Just real quickly here, let's look over. We are sitting at about 3.3 gigs of process memory, a little under that. Yeah, right about 3. I don't know if that's some sort of like cap or something like that. And this is with physics, the physics processing happening in a separate thread from rendering. Now, we could smooth this out a little bit by saying that physics happens 30 frames a second instead. But we do want to shoot for more. Like, we want it to be at least 60. Not because that's necessary, but because 60 is pretty smooth for sprite animation. 30, it does get a little choppier, less than that, more so. I mean, of course, we are using delta time and similar, but... Welcome back, Lore. We're stress testing, as the number over my right ear might imply. Processor is screaming right now. We have definitely achieved seconds per frame here. But for science... Okay, with the menu open, which means nothing is moving. Yes, we could, Lunar. What was it? Rogue Genesia has options like that, like maximum number of things on screen, that sort of thing. There's even a joke character related to that is like a super pixelated version of the player character. Okay, so yeah, we can recover up to frames per second if we're not processing the explosions. Can we make this worse? Do I have something to make it worse? I don't think we do as far as multipliers. We're already doing... Let's see, that is 3 to the 5th, so 81... 405 projectiles emitted per second. Each of those is doing the rotation logic, and then every second each of those is emitting an explosion. Plus rendering, plus physics. But we can see we can get to about 12,000 things. And the game still operates. So yeah. This math still isn't good enough. I has a sad. I don't know why. Splits on impact would be a thing. That would be an interesting... That could be a heart. They're so... Like, the sky's the limit on this. I do get into the weeds as far as optimizing stuff here. We are pretty much at the point where we could be making new stuff. New movement systems in place. There still needs to be a polish pass to account for that in all of this stuff. Making sure bouncing, wave, all of that is working. Oh, well, yeah. I mean, if I want to stress test further, I just need to add another ×3 to the loadout. Or replace the ×3s with ×5s. I'll have to look at this further and see if we can find how to get this fully functional. Because we need that X to properly account for it. Yeah. So we'll need to figure out how to actually calculate this properly, because this seems like it should be working. But we're still not quite getting the multiplier correctly. So we'll have to see what we need to do to correct that. But with that said, we got a lot done today. We got our rotation finished up. I'm pretty pleased with where we've got on that. Is there still more we could do with orbit? Yes, but again, I think we're in a good spot. The oscillating motion still needs work. It is functional right now, so we might need to leave it at that. Like I said, I would still like to get a calculation for how much faster the projectile needs to go to account for the extra time. But we'll see we'll see. Hopefully what that means is we're going to get into some new things so that we can start, if we keep expanding the stable of kind of micro level things that you can do, eventually we're going to hit the point where we start creating sort of finished product items, where this is something that the player could expect to encounter and it would be neat, as opposed to something that just makes the projectile move all wonky. But yeah, I hope everybody had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, drop a comment. All of those buttons are generally good. So press them. It helps the channel grow. If you'd like to consider financially supporting the channel, you can do so through platform-specific means like subscriptions and memberships, bits and super chats. Otherwise, you can use things like Patreon and Coffee. Links to my various channels and such are in the description and in my profile. With all that said, I hope the rest of your day is good, and I'll see you next time.